Express this expression in terms of sine 2 theta and cos 2 theta only. So sine 2 theta can be written as 2 sine theta multiplied by cos theta, and cos 2 theta can be written as 1 minus 2 sine squared theta. So sine squared theta is the same as 1 minus cos 2 theta all over 2. We can write our expression as 6 multiplied by 1 minus cos 2 theta all over 2, and given as cot 2 theta is the same as 1 over tan 2 theta, we can write 1 over tan 2 theta as cos 2 theta all over sine 2 theta. We can write cot 2 theta as cos 2 theta all over sine 2 theta plus 2 lots of 2 sine theta cos theta. So we have 3 multiplied by 1 minus cos 2 theta times cos 2 theta all over sine 2 theta plus 2 sine 2 theta. So the final answer is 3 minus 3 cos 2 theta multiplied by cos 2 theta all over sine 2 theta plus 2 sine 2 theta. In the second part of this question, we need to show that this equation can be written in the form 5 sine squared 2 theta plus 14 sine 2 theta minus 3 equals 0. So using the answer from the previous part of this question, we can write this as 3 times cos 2 theta all over sine 2 theta minus 14, and that equals 3 minus 3 cos 2 theta multiplied by cos 2 theta over sine 2 theta plus 2 sine squared 2 theta over sine 2 theta. And after we set this equation equal to 0, we get this. And after we multiply this entire equation through by sine 2 theta, we get this. And given as we need to write our answer in a form that's only in terms of sine 2 theta, we need to replace cos squared 2 theta with 1 minus sine squared 2 theta. And that gives us this. And after expanding and simplifying the left-hand side of this equation, we get this final equation. And in the final part of this question, we are told to solve this equation, giving our answers to 1 decimal place. So when we factorize this quadratic equation, we have 5 times sine 2x minus 1 multiplied by sine 2x plus 3, and that equals 0. So 5 sine 2x equals 1, therefore sine 2x equals 1 over 5, and so 2x can be obtained by taking the sine inverse of 1 over 5, which is 11.5, and given as the range for x lies between 0 and 90 degrees, we need to double this range in order to get all the suitable values for 2x. So given as 2x equals 11.5, which is somewhere here roughly, we can extend this line to where it next meets the curve, and we can draw a vertical line to the x-axis, and we know that this distance, which is 11.5, is the same as this distance. So if we subtract 11.5 from 180 degrees, that gives us 168.5 degrees. Therefore, the values for x can be obtained by dividing each of these values by 2. So we get 5.8 degrees to 1 decimal place and 84.2 degrees to 1 decimal place. And given as sine 2x equals minus 3, we will have no real solutions because the minimum value for sine 2x is minus 1.